All right, next, let's consider this scenario. You pay $1 to play a lottery game. All right, so each time you play this lottery, you pay $1. Okay, 1 in 100 people would win $10. 1 in 1,000 people wins $500, and that's it. Okay, that's a small lottery. Okay, nobody's going to win like multi-million dollars. What is the expected value of this? Now, again, there is a formula using a weighted sum. You don't have to know that. I don't want you to think in terms of that formula. I want you to think in terms of this intuitive approach that makes sense, which is easy to convince others with and easy for you to understand this with. Okay, remember, this class is all about thinking and problem solving. What's a good way to think about this? All right, so you have 1 out of 100 and 1 in 1,000, right? Let's buy all 1,000 lottery tickets. Okay, sounds crazy, but that's a good way to think about this. All right, so I'm going to buy 1,000 tickets. Okay, now 1 in 100 people would win $10, right? But I'm buying 1,000, so 1 in 100, that's 1% of the people will get $10. So 10 of these tickets, 1 in 100 means 10 out of 1,000. 10 tickets win $10 each. So that's the gain of $100. And then 1 ticket out of the 1,000 is going to win the grand prize of $500. These are my gains. My gains total $600. That's great, okay? But remember, when you buy 1,000 tickets, you spend $1,000. So in winning 600, you are losing 1,000. So your net gain, that is the gain minus the loss, is negative 400. Okay, how many tickets did you buy for 1,000 tickets? So you divide this net loss by 1,000, and the answer is negative 0.4, which is minus 40 cents. In English, what this means is every time you buy this lottery ticket, you are losing on average 40 cents. Okay, so the expected value is going to be negative 40 cents, or you could say the loss of 40 cents per ticket. Okay, so this is much easier to understand, I think, than trying to use that formula. Okay, so here's a sort of an application of this in sports, right? After a touchdown in football, you have 2 choices for that extra point or points, right? Suppose there's a 94% success rate for 1 extra point. You kick the ball between those 2 posts and you will get a 1 extra point. Or you can go for a play and have 2 extra point plays, right? But that's not very that's not as successful as the kicking to get the 1 extra point. Let's say you have a 37% success rate for that 2 extra point. You see what the probability is? Like for instance, if you play this 100 times, okay, I think maybe this will be easier. Let's imagine 100 touchdowns, okay? And if you try each of these times, if you try a 1 point field goal, 1 extra point attempt, then you get 94%, right? So if you have a 94% chance of converting for that 1 extra point, you're going to end up with 94 extra points if you kick the ball for that 1 extra point each of the 100 times. Right? And of course, if you miss it, you don't get any points. So there's no net loss or anything, right? So that's the 94 points. But 94 divided by 100, that's 0.94. So you are, this is going to be similar, but you're expecting to get 0.94 extra points each time you attempt for that 1 extra point play. On the other hand, if you try for 2 extra points, let's say you do this 100 times, okay? So if you try So 100 times, and then you try a 2-point conversion play, then you only succeed 37 of those times. So 37 of those times you will earn 2 points, or you will get 2 points, and that turns out to be 74 points. Okay, and so 74 points out of 100 is of course 0.74, and that is your expected value. So expected value, the number of points per an extra point play, if you choose to go for the 2 extra points, is 0.74 per play. Clearly, this is better. And this is why most times when a football team scores a touchdown, they will go for the kick for that 1 extra point as opposed to this, because this is much harder. All right, so the expected value actually determines a lot of the decisions made during a sport game. Whether it's like, play on the free kick of a soccer or penalty kick, or what kind of a pitch you are going to pitch to a particular player, whether he is a right-hand hitter or a left-hand hitter, and so on. Many times, many of these decisions, maybe all of the decisions, are based on these expected values. Okay, and speaking of all kinds of situations, think of these. Should I drive at 80 miles an hour to make it to my math exam? Well, it depends on how important this exam is, right? No, it's probably not worth it. But if you know that you can get away with it, then the penalty is low. Your expected value of the penalty is low, and so you may do that. Now, if you try to do it for 90 miles an hour or 100 miles an hour, now the risk is much higher, right? The expected value of how much you would have to pay, and again, the probability of being caught and getting a ticket may be low. But if the penalty is high enough, the expected value would be also high, the expected value of how much you would have to pay. All right. So think of the expected value idea as the product of the probability and the cost. Okay, that's a way to think about this. And in fact, that weighted sum approach is exactly that. But this could be done by many people. This is probably not. Hopefully, not many of my students will do that. All right. So that's the difference that the expected value makes, and that changes people's behaviors. Right. Should you park illegally for 5 minutes if you have to? Well, sometimes, yeah, that is, sometimes we may do that. How about for an hour? Probably not, okay, because the risk of getting caught and having to pay money here is a lot more, okay? How about parking in the disabled car when you do not have disabled, license plate? Okay, well, you don't do that, okay? In fact, most of you will never do that, not even think about doing that, because the penalty is much, much higher, right? Even if the probability of being caught may be less, because the penalty is higher, the expected value would increase. That's the expected value of the penalty you have to pay. And that's why you don't park your car illegally on the disabled parking space. And of course, the government knows that. So the government uses expected values to make policy and make decisions in laws and regulations. What are the details you need for this calculation? Yeah, so the answer here, don't do that. And so this has to do with a penalty. And so what kind of things do you have to know? What is the probability of, if you're talking about parking illegally for 5 minutes or an hour, probability of getting a ticket? Within 5 minutes. Now this may be low, okay? And within an hour, that's 60 minutes, this may be high, and that may determine what you want to do. And also the penalty itself, okay? So let's say the probability of getting a ticket, maybe within the next 5 minutes could be extremely low. But let's say if you are ticketed because it's a downtown of a major city, you may have to pay hundreds of dollars. Okay, that would change your mind. And you say, well, I'm not taking the risk. All right. So the expected value idea, the idea of expected value is something that is very, very closely related to the way we live and the way we make every decision. So keep that in mind as you live your life. Okay, so that actually is the end of chapter 4 and of section 4.4. All right, go ahead and do your quiz. Make sure you answer these questions on paper before you go on to the online quiz for section 4.4. All right, so with that, I will see you and take care until we meet in chapter 5.